Good morning, everybody, and thank you for joining us. And for those of you who don't know me, I'm Rosemary Collier at the University of Warwick, and I'm the one who's been bombarding you with emails. Basically, this is a pretty informal meeting. We've held a meeting like this probably for the last 3 or 4 years. At first they were in person, but because of COVID we went online, and actually I think we save a lot of carbon by doing it online. So just to ask you again, if you can mute your microphones and switch off your cameras, please, just not to overload the system. Please note that we'll be recording the event. So I guess if you switch on your camera, you will be visible in the recording. We very much welcome discussion and questions. I know that can be a bit tricky online, but it would be great if we can have some discussion. We'll have questions after each presentation, and please could you try and use your virtual hand to indicate you'd like to ask a question, and then you can ask it. You can turn your microphone on and ask the question, no problem at all. So basically what we're going to cover between us all are mainly the sort of research activities that have been ongoing in the last year, but it will include some earlier stuff as well as background and for completeness. So we're going to talk about some work on insecticides and bioinsecticides that has been funded by AHDB. We're going to Becca McGowan is going to talk about her PhD project that's funded by AHDB, PGRO and Warwick. I'm going to mention some work on smart traps, which is funded as part of an EU project, and then Simon's going to give us an update on some trials work from Syngenta as well. So this is the batting order. I don't think it's going to take as long as the slot we allowed, but we'll just see how it goes. And as I say, it also depends on how much discussion there is. So I think I've probably covered everything. So what I'll do now is I'll unshare my slides and hand over to Becky Howard, who's going to do the first presentation.
Morning, everybody. Let me just share my slides and then share. That's not. Can you see that as a full screen, Rosemary, or is it?
Yes, I can. Yes.
Yeah.
Brilliant.
Okay. Brilliant.
Okay. Yeah.
Okay. So, morning, everybody. It's good to see so many people here. There's obviously still a great deal of interest in this topic. I will talk about the work that we've been doing over the last 3 or 4 years to recap a little bit, and then also the work that we've done this year in legumes for control of bean seed fly larvae. And some of you will have seen some of this before, but it's just to recap on where we are with it. So the pest itself, as many of you know, if you're growers, has a wide host range, affects over 40 plant species and is distributed quite widely. It's become a problem in the UK recently. It's always been a problem, but more recently, because at one point we had seed treatments that were on imported seed for peas and green beans, and since we no longer have those, in the last 4 or 5 years, damage levels have increased. So the flies are often associated with soils that have high levels of organic material, particularly things like green weed cover and farmyard manure and other plant debris, and they do prefer recently cultivated soils. So I'll talk a little bit more about that as well. And the damage is to peas and beans is seed and stem tunnelling by the larvae. Now this pest has a 3 or 4 week life cycle, so it has overlapping generations throughout the season from when it starts emerging. Now in the UK and most regions it starts to emerge approximately in April. But worst case scenario for peas and beans is that you get significant establishment losses very early, and re-drilling is not always possible because obviously you've got these overlapping life cycles, so it is a tricky pest to manage. One of the things that we have done in conjunction with AHDB and Warwick is to set up a reporting page on our PGRO app. So I just want to remind people that this is available and it will always be available. So I know some people have used it. It's really helpful from the point of view of getting an idea of what's happening and when it's happening. So you can download our PGRO app and the report pages in that. And you can report for any crop. So bean, seed fly, and any crop, you can report it on that app and it will go onto a map that ends up on our website. So if you want further information, go to our website and you'll find the link for that. So when we started to do the work to try and sort of manage the pest a bit more effectively, we started with a survey, and that was conducted mainly in Yorkshire and Lincolnshire on the wolds, and we were using attractant traps with lures that we were buying from America, were developed in the US. And over the 3 years, we've been monitoring at 27 sites in total between 2019 and 21, and we've done a few more in 2022 as well. We also wanted, as well as to look at whether monitoring would help to determine peak sort of period of activity, we wanted also to look at sowing timing in general related to that, and also related to the period between cultivation and drilling. We have looked at drill type, direct drilling, min-till and drilling depth in the past, but we haven't actually had very conclusive results from that. So we really only did that in the first year or two. And for our purposes in legumes, we've also looked at the influence of bean seed fly damage on foot rot infection in peas, which is the soil-borne diseases that affect the roots and the plant. And we've had some preliminary looks at an entomopathogenic nematode for management at field scale. So for monitoring, as I said, most of this work was done in Yorkshire and Lincolnshire with Swaythorpe Growers, Pea Group and Stem Gold Peas. It's a very simple trap and it is now available commercially in the UK from Copper UK. So if you want to use it, it's easily available. And we put these out as early as we can. We were heavily dependent on the grower group managers to help us with collecting sticky cards to send to us. So, you know, they've been really great and, you know, they're monitored throughout the whole season. So that's been really a real help, actually. But you can see from some of these images that, you know, the impact of bean seed fly damage can be quite significant when you look at sort of establishment in the field. When we look at certainly the first 3 years, and when you're comparing the average of the number of sites that we did in each region, so Yorkshire's along the top and Lincolnshire along the bottom, what's noticeable, I suppose, to start with is there are some quite big differences between the date of that first peak. So anywhere between mid-April and mid-May. And what also happens is that you get subsequent peaks, and that's due to the overlapping life cycles. So you can see there's some big difference between years, certainly in the date of emergence. And there are actually some differences as well between the regions. And we know this, you know, from the Warwick data for trapping as well, that they can sometimes get quite early emergence at Warwick Crop Centre. Also, if you look at that first Yorkshire peak in 2019, we're recording there an average of 300 adults on a trap, so that's very high, and on most of the other sort of monitoring sort of areas and years, it's a little bit lower. And in 2022, surprisingly, actually, we see that the number of adults that were recorded on traps was not, you know, anything like 300 as an average. So for the 5 sites in Yorkshire, we've got up to, you know, 120 odd. And then for Lincolnshire, it was a bit lower. And actually in peas this year, I would say damage in many cases was a little bit lower than we might have expected. However, for green beans in 2022, it was an incredibly difficult year. and high levels of damage were sustained certainly in the green bean trials, and in grower areas. The growers that are growing green beans in Norfolk had some very high levels of damage there as well. So as an overview of the 2019 to 21 survey, there were a few points that came out of it, really. There were, as I said, there were differences in timing of peak adult activity in the different regions. If you look at the figure on the right, you can see that the period 10 days before and after peak activity was the highest risk for drilling. So if you're drilling around that first peak, that was your high risk period. And I'll show you another figure in a second that shows that the period between cultivation and drilling seemed to have quite a strong effect on damage levels. And damage varied significantly between years as well. So when we look at the period of cultivation between cultivation and drilling, so this is number of days along the bottom and mean percentage damage at the side, you can see that the longer period you leave between cultivation and drilling, the better. And when you're cultivating and drilling within that sort of 5-day period, you get very high levels of damage in a lot of cases. So we followed this up actually by doing small plot trials to look at whether we could determine if cultivation was timing was impacting on bean seed fly. And in both 2020 and 2021, you can see, so basically along the bottom you've got drilling minus no days, drilling minus 7 days, drilling minus 13 days, 21 days and 28, and the same in 2021 more or less. So at weekly intervals, and in both years at the first assessment you can see there's a significant difference in the level of damage. So there's higher damage when you drill and cultivate, or when you cultivate and drill on the same day. This was done at field scale in Yorkshire in 21 as well. And the orange line is where there's only 1 day between cultivation and drilling, and then we've got periods of 2 weeks and 4 weeks, and you can see the level of damage is significantly higher. Although stats are a little bit tricky on these large scale trials. These were non-replicated large strips in a field. So, however, you can still see there's a difference. In addition, last year we also did the work looking at the entomopathogenic nematodes. So we had 4 treatments: untreated, an application at 2 days after drilling, an application at 4 days after drilling, and 1 at 6 days after drilling. And again, the orange line here is the damage, and you can see that this looks reasonably hopeful. So we will pursue this work, as well as leading into the work that we did in 2022. So at Warwick Crop Centre and also at our trial ground at Stubton, we did efficacy trials looking at different bioinsecticides and chemical insecticides, but in furrow mainly. Hallmark was sort of put in as a standard really, and that was a ground spray at weekly intervals for starting from drilling for a couple of weeks. So, but as I said, actually, we drilled our first trial on the 5th of May in 2022, and at Stubton we had very high levels of damage. And I don't know how easily you can see it. It'll depend on how big your screen is, to be honest, but the image on the left shows the trial that we drilled first. So on the 5th of May we drilled it. We normally apply layers mash or fish and bone meal to the plots in order to attract the pest into the plots for bean seed fly, and that helps to sort of give you enough damage to assess. And in this trial we did that, and we did not do it on the discard areas, which you can see directly in front of the camera there. And what that meant was that the whole trial got completely decimated by bean seed fly larvae, apart from those discard areas. So we had to re-drill it. And we re-drilled on the 17th of June and assessed on the 30th of June and the 1st of July. So it's quite a big assessment. It takes quite a long time, so that took 2 days. Unfortunately, although there were quite a variation of products in there, at our trial, there were no significant differences between any of these. So if you look at the orange lines there, you can see there's some minor differences in terms of the level of damage, but nothing is giving significant control. And when you look at them, they're in between 70 and 80% damage. So that's really very high. Some of the plants are still growing, but the damage ultimately means that many of them won't reach maturity. And here's just a few images of the damage. So for green beans, what you see is very strongly the stem tunnelling here, and green beans are not able to compensate for this damage, so they die. The other thing that happens when you get this damage to the cotyledon or the stem is that you get a symptom called bald head, which you can see in the right hand image, which is basically a barren plant, and that also will not mature and won't form any true leaves. So quite significant levels of damage. And at Warwick, the experiment was repeated there, and you can see again there are some slight trends in terms of levels of damage, but actually no significant differences here. So you do get slightly higher emergence for a couple of the products, but they're not significant. And so at the moment, I think what Rosemary's going to talk to you in a few minutes about some pot work that they've done as well, so which is showing a little bit more promise. But at the moment in the field, we're struggling to get these in-furrow products to work very effectively. Just on the Warwick trial, those emergence figures represent roughly 25% of what was drilled in the plot, so very low emergence. So I think that's everything I wanted to say. I just wanted to thank again Matthew and Nick from Swaythorpe, and Ewan and Ian from STEM Gold, and then Liz and Phil for monitoring and always recording and sending me reports of what they find. So, and my colleague Joe for sitting and identifying flies for the season. So also to Dyson Farming for hosting the trial at Stubton, and Warwick Crop Centre for the second one. And please do download the app and do report this year again. We'd like to keep up to date with that. So and that's everything. I'm going to try and unshare now, Rosemary, hopefully. So
Brilliant. Many thanks, Becky.
You're very welcome.
That's great. So has anybody got any questions for Becky? Any points they want to raise? I think there is a sort of interesting point about you this year. You caught low numbers of flies at your trial site, didn't you? And we caught relatively low numbers of flies, and yet we still both got wipeout in our trials.
Absolutely, I know, and that's I think a subject for further discussion actually, to see why that might be the case. And because I mean I think at maximum at Stubton we caught about 65 on the trap, so that's low considering, you know, as you say, there was a complete wipeout on that first drilling, and actually the levels were 70 or 80% on the second drilling. So be interesting to know what that is, what's caused that. So don't know if anybody else has got any ideas, but I'd like to hear them. Have you had any thoughts about that, Rosemary?
Yes, possibly a few, but actually Jenny would like to ask a question, so I'll let Jenny. Jenny, do you want to unmute and ask?
Hello, morning everyone, and happy New Year. Yeah, thanks for that. I just wondered with the traps that you showed, were they yellow sticky traps, or I think previously we've been told it's better to use blue ones. What would you say?
Yeah, we used yellow ones. I think that was the image that I put in, but actually this year we used blue ones. So the yellow ones were used in the first year, and then I think we've switched to blue now. So I just need to get a new image for it. But yeah, blue, I think, was decided that was the best colour, wasn't it, Rosemary?
Yes, and Becca may say something about it later, but blue traps make them more selective for bean seed fly. So particularly Stan Finch did work years ago. You catch relatively more bean seed fly to cabbage root fly on blue traps. So in terms of sort of mixing them up, cabbage root fly is bigger, but it still can be quite tricky. It's better to use blue traps. and they are attractive blue traps. So yeah.
Thank you.
And we've also, both of us, all of us, use the attractant that you can buy. And again, I think Becca may say something about that as well, which will increase numbers of bean seed fly. And Becca has been looking at whether that might or might not make the traps more selective, which again, for bean seed fly, which again would be very useful. Yeah, yes, Becca said she's going to talk about monitoring. So yeah. So in all of this, there's still lots to think about and discuss. Patrick, would you like to unmute, ask a question?
Yeah, just a quick question. Any thoughts on companion crops or trap crops that sit alongside?
We've not done any work actually looking at that yet, but I think you have, haven't you, Rosemary?
Not specifically for bean seed fly. It's it's a really good question.
It is, yeah.
And I think one of the, in quotes, problems about bean seed fly is that it's a generalist. So the trap where we've been looking in the past at trap crops or companion planting, it's been for insects that specialize in one plant family, like brassicas or carrots, when you've got a lot more scope. But so I think we're still really unclear where that population of bean seed, you know, the sort of national population of bean seed fly actually lives and multiplies, because it could be on a whole, you know, a whole range of things that we, you know, our focus is I guess horticultural crops in the broadest sense, but they may be elsewhere. So it's a whole new topic, I think, in terms of bean seed fly. Yep. So yeah, okay, right. So I think it looks like we'll move on for the moment. So thanks again, Becky.
Thank you.
So now I'm going to share my slides. Right, can you see them, Becca?
Yes, I can see a full screen.
Brilliant. Okay, thank you. Right, so I'm going to cover again some trials similar to the ones Becky's talked about, but the trials that were done on allium crops, and then talk a bit about the smart traps and trapping. So first of all, I thought I'd just put up the slide showing the sort of pattern of bean seed fly abundance activity at Wellesbourne in 2022. Alla, the discussion about blue traps, we use yellow traps as our standard monitoring tool because we monitor all sorts of pests in them, and yellow's the best colour. And we have got a pretty extensive data set now for here, going back 20 or more years on bean seed fly numbers and all the other pests as well. So what appeared to happen in, again, low numbers overall captured. This is bean seed flies per trap per day, but you can see that they were sort of relatively abundant at the beginning of the season. Then there was a period when they were less abundant, and whether that is due to the drought conditions, which maybe sort of slowed up their sort of reproduction a bit, or even caused them to estivate, so go into a sort of summer hibernation. And then numbers increased again in sort of from September onwards. And just to make the point, and again, Becca will be talking a bit more about their life cycle, we're still trapping them. We now have the traps out all year, and the traps were visited this week and there were being seed flies in them. We did stop capturing them where the red arrow is when it got extremely cold. But they do have a very different life cycle from their relatives that we work on, like cabbage root fly and onion fly. So again, we use the same treatments in our field trials as Becky did. So 2 insecticidal granule treatments, 3 spray treatments, one of which was coded, and then a biological spray treatment and a biological granule treatment, which was NemGuard, which in some of our slides is coded and some isn't, so I'm sorry about that. The first trial that we did with AHDB funding at Wellesbourne was on leek, and the leeks were sown on the 21st of April. Again, we took actions to increase the infestation by bean seed fly, which probably in retrospect was a mistake, because again we got a huge infestation, very low percentage emergence. If you look at the right hand axis, you can see we got up to just under 10% emergence, and none of the treatments, there were no treatment differences, and anyway so much of the crop was wiped out. So exactly the same result as Becky. And then G's very kindly let us undertake a trial on part of their salad onion crop near to Wellesbourne, and the salad onions were sown on the 18th of May. And in this case, I think there was a much lesser bean seed fly infestation. Overall emergence was pretty good, I guess around 80%. We assessed them on 2 occasions, counting the plants. There were no statistically significant differences between treatments. There was some force treated salad onions in adjacent beds, and there was actually little difference between them and the untreated control either. So I guess in this case we didn't get sufficient infestation to, I guess, test the treatments out. And just to point out that NemGuard, I say some of the time we've been coding it, some we haven't, but it's not currently authorised for use on salad onion in the UK. But yeah, it was worth trying it out in the trial. And then Becky mentioned that we have quite recently undertaken a supplementary pot trial here at Wellesbourne, and we were able to do that because Becca has very successfully established and maintained a bean seed fly culture for her PhD project. So we were able to use eggs from her culture. So basically we sowed French bean seed in pots, and then we Andy Dukes and Marion Elliott, who worked with me, did this, and then they put pre-weighed granule samples. So it was a trial using the granule treatments. So the granules were applied quite precisely in the pots, and then the pots were topped up with compost. They were inoculated with 20 bean seed fly eggs per pot, and then they were caged and kept for a couple of weeks at 20 degrees C, and then the seedlings were scored for damage, and then they were subsequently dissected to find larvae, and then we actually extracted pupae from the compost. And so yeah, it was the 3 granule treatments, including NemGuard, which is 9896, plus an untreated control. And what we found, which was quite interesting, was that one of the insecticidal granule treatments appeared to work quite well, statistically significantly different in this POP trial, 9833. And that was, I guess, despite quite high insect pressure. And there is now, I guess, a big question about why haven't we got treatment effects in the field? Is it something to do with the positioning of the granules relative to the bean seed, or is it some other factors such as temperature and the relative rates of growth of the beans and of the bean seed fly? So that's the damage score. And this is the recovery of larvae and pupae per pot, again showing that the one treatment appeared to be much more effective. There was a difference. So we did this trial in two batches, and there was a difference between the two batches, even though they were in the same controlled environment room. So it does suggest that even sort of subtle differences in conditions may lead to quite large differences in survival. And we've been thinking about it, and obviously the bean seed fly, we put on loads of eggs relatively, and if they'd all survived, well, the bean wouldn't have supported them through to pupation. So there's all the time must be competition going on between the larvae that hatch, and again, I guess how that competition occurs may affect what sort of happens in the end. I just wanted to finish by mentioning the work that we've been doing on smart traps, and this has been mainly as part of an EU project called Smart Protect, where we've been looking at smart tools for crop protection in vegetables, both outdoors and in protected crops. And we've been looking at all sorts of things, but of interest to us has been these traps, which basically have a camera in them. Some of them are pheromone traps, so there's a traps for a range of species. So some of them are for things like diamondback moth, silver wire moth, but they're also testing out, a couple of the companies are testing out systems where you can use sticky traps, so visually attractive sticky traps. So there's a carrot fly one on the left, and then a different system with a bean seed fly trap on the right. And they work reasonably well. They don't work so, I mean, the image is the important factor that you get, and if it's rained a lot, then the image can be pretty poor. And the challenge with bean seed fly in particular is identifying them from an image, because in the lab we might actually need to use the microscope to separate them out. So to a certain extent there's an element of guessing, but I guess that information is still more useful than none, and it means you can look at your traps every day without visiting them. The other key issue that I've noticed through us using the traps, and we've been working with some agronomists and growers as well with the bean seed fly traps, is that you can't forget about the traps, and when they get full of flies, then they cease to be attractive. So it's important to actually replace them at regular intervals if you want to get reliable data. So again, I'd be interested in any feedback, comments on those traps. So just to conclude, so as with Becky's trials, none of the treatments managed to deal with the large infestation of bean seed fly. In the lab trial, there were some treatment differences, which I think has just given us more to think about. And using the traps, you can monitor bean seed flies remotely, but you do need to manage the the traps and replace the stickies regularly. And again, I think there's more to think about in terms of monitoring and how that information is used in the future. So I'll stop by saying thank you to the funders, to the BGA, crop associations, to our collaborators, and to the team at Wellesbourne. And I'll stop there and I'll unshare my slides as well. So again, has anybody got any comments, thoughts about any of that they want to add at this moment? Just to say that Carl Sharp has been running smart traps, but smart pheromone traps during 2022 as part of a Syngenta project, and he's also got a lot of useful experience about using them. Okay, so it's like there's no questions or comments. So Becca, should we go on to you then?
Yes, I shall just share my screen. Okay. Rosemary, can you let me know if you can see
Yeah,
this?
looks good to me.
Okay, great. Thank you. Hi everyone. For those who don't know me, I'm Becca. I'm Rosemary's PhD student, and my PhD has focused on the bean seed fly. I'm now in the 4th year of my PhD, so I'm in the final year of it now. And so yeah, I've presented at these meetings for the last couple of years now. And I'm going to give you an overview of what we have found over the last year. So yeah, I'm just going to give a brief introduction, but I know that we have covered a lot in this introduction already. And then this will lead on to my aims and objectives of the PhD. I will go through a selection of my findings from this year, and then I will talk about what we think these mean. So as you're aware, the bean seed fly is is a complex of 2 species. It's Delia platura and Delia florilega. And as what has been said by Rosemary, is that to differentiate these species, you need to look at them under a microscope. Another thing that you're aware of is that they are a pest because when they are a larvae or maggot, they feed on the seed and stem of a variety of crops, but mainly in the UK it's reported on beans, peas and onions. So these are just some pictures showing damage, and Becky has gone through this already, but the top right one is showing damage getting predominantly worse as you go to the right, and you've got bald-headedness on the right there, which is lack of development from the cotyledons in beans. And yes, so there's a lack of effective insecticides available at the moment to control for bean seed fly. So we need an alternative solution, more of an integrated pest management strategy. So that's the aim of my PhD, is to contribute towards an integrated pest management strategy to reduce crop and economic losses by the bean seed fly. And so to do this, I have 4 objectives focusing on preventing bean seed fly from being there, monitoring bean seed fly, then doing some more fundamental work in the lab, which is looking at its biology, and then the information from the work in the lab will go on to create a forecast to predict the spring emergence of bean seed fly. But being conscious of time, I'm just going to speak today about objectives 1 and 2. So more specifically, objective number 1 is to assess cultural and interference strategies on reducing damage by bean seed fly. And 2 is to identify effective trapping methods for monitoring bean seed fly. So I'm now going to take you through some results from this year, or I say this year, 2022, on preventing damage by using cultural and interference strategies. So what do we already know? So and as Becky has said, cultivation, so bee and seed fly are stimulated to lay eggs in areas of high organic matter. And we also know that potentially covering a crop may stop an insect from laying its eggs, which then will go on to cause damage. So knowing this, we asked 2 questions. One is, can the timing of cultivating a plot in relation to sowing the seed reduce damage caused by bee and seed fly? And 2, can the timing of covering a plot with a fine mesh in relation to sowing the seed reduce damage caused by the bee and seed fly? And why is it important to ask these questions? So regarding number 1, which is cultivating, if we delay cultivation, the idea is that the insect will lay its eggs, maybe depending on when you do the cultivation before the crop is sown, they will hatch, they may not have anything to feed on, so then they will die. So when you plant the seed, the larvae won't be there, preventing the larval feeding. And number 2, as I said, if you put a crop cover over the crop, even if the flies are attracted to lay their eggs there, they physically won't be able to get to the soil to lay their eggs. And that is where bee and seed fly are laying their eggs, is in the soil surrounding the crop. So to ask these questions, I had a replicated field trial. So from 2021 to 2022, over 2 summer seasons, we did 7 trials in total. And so I'm just going to take your attention to the table here. We had cultivation treatments which were similar to Becky's. We cultivated 21 days prior to sowing, all the way up to day 0, which is cultivating on the day of sowing. And then if we look at crop covering, we had 3 treatments. One were plots that were not covered, and all of these in the crop covering plots, they were all cultivated on the day of sowing. So in theory, the flies are attracted to those plots to lay their eggs. And then we had treatments that were covered on the day of sowing, and then we delayed covering by a day. So the crop was sown, we left it a day, and then those plots were covered. In 2021, we did the experiment with vining peas, and in 2022, we did the experiment with French beans. We used the power harrow for cultivating, and a fine mesh was used to cover the plots. So these pictures here are just showing some of the assessments. So in the top right over there, we've got the number of seeds / plants containing larvae. So you can see a larvae on a pea seed there. In the bottom right, we've got tunnelling by bee and seed fly in peas. So you can sort of see the holes where bee and seed fly has been feeding there. In the bottom below the table, we've got bold-headedness. Again, that has been described already, but that's lack of development from the cotyledons or a lack of development of true leaves in beans. And I also counted sort of the amount of plants to emerge per plot as well. So what I just need to say is in 2021, we had really low numbers of bee and seed fly at Warwick Crop Centre. So we think this meant that we had low levels of bee and seed fly damage at Warwick Crop Centre. So I didn't really get any significant findings in 2021. In 2022, though, the first trial I did this year, back in May, was using vining peas again. And we didn't really see a significant difference, but maybe a trend. So these graphs here are showing the mean proportion of plants with tunnelling in the seed. So that's the picture, as you can see in the top right there. And what we can see is that as cultivation gets closer to the day of sowing, there is an increased proportion of plants with bee and seed fly tunnelling in them. And on the right, we've got, as you may expect, is that in the plots, that all of these plots were cultivated on the day of sowing. On the left, the bar that shows that there was no covering of the plot. There is increased levels of bee and seed fly tunnelling. But yeah, there were no significant differences. I also think there was a high level of disease earlier this year in the peas in the field. Potentially, we did use a different site, so maybe that could have. It was quite hard to sort of differentiate between disease and maybe bean seed fly tunnelling. So, but yeah, so moving on to French beans. And so we did find significant differences with French beans. So this was sown, this trial was sown in June in 2022. And these graphs are showing the mean number of plants to show the bald-headed symptom. So you've got a picture of the bald-headed symptom above there. And so when we look at the timing of cultivation, we found a significant difference between the plots that were cultivated on the day of sowing and those that were cultivated 7 days prior to sowing and 21 days prior to sowing. So that's kind of similar to what Becky saw in the vining peas. Up to 7 days, there was a significant difference. And so what this graph is showing is that there are increased numbers of plants that are bald-headed when they are cultivated on the day of sowing. On the right, we have the timing of covering, and we saw a significant difference here. So those plots that were covered on the day of sowing had significantly less plants that showed bald-headed symptoms than those that were not covered or, interestingly, covered the day after sowing. So what is this? This is implying that if you do cover your crop once you sow it, you need to do it as soon as possible. Another thing that we saw on the same field trial is that there was significantly less plants showing the mean number of plants showing no symptoms of bean seed fly damage in those that were cultivated on the day of sowing, and that was significantly different from those that were cultivated 7 to 21 days before sowing. And so those plants were ones that had sort of no lesions in the leaves and they were not bald-headed. And so all of the assessments were done in seedlings. In the second replication or repeat of the field beans trials, so these were sown in August, we saw a significant reduction in plants that had emerged per plot when they were cultivated on the day of sowing compared to those that were cultivated 7 days prior to sowing. And that was interesting because we had reduced bean seed fly numbers in our water traps at this time. So what can we conclude? So can the timing of cultivating a plot and covering a plot with a fine mesh in relation to sowing the seed reduce damage caused by bean seed fly? Yes, our experiments are saying yes, it can, but our experiments are saying this is in French beans only. So considering the information we've gained, at the moment, it would be best, the experiments are saying that if you do delay the cultivation in relation to sowing the crop, it needs to be done at least 7 days prior to sowing, according to our field trial that we did. And then when it comes to covering the crop, if you were cultivating on the day of sowing, but you cover the crop, you need to cover the crop as soon as possible. And again, just talking about the vining pea experiments, we had low levels of bean seed fly damage in 2021. This might have been down to low levels, and then this could have correlated to low levels of damage. And in 2022, there was increased disease in the field there. Or we also had some other trials that Rosemary and the team were doing that year at the same time. Were the bean seed fly more attracted to those trials? I don't know, but that was just another idea as well. So objective number 2, which is monitoring the fly, and these are experiments that I've done in 2022 on monitoring the fly. So what do we already know? So bean seed fly can be easily confused with similar species, and Rosemary spoke about that. But just to highlight or show a picture of it, this is a yellow sticky trap here. On the top row, we have bean seed fly, and on the bottom row, we have cabbage root fly. You can see that there is a size difference, but they can easily be sort of mixed up, especially when they are next to one another. Sticky traps catch more bean seed fly than yellow water traps. That's been proven in previous experiments. And blue sticky traps catch larger ratios of bean seed fly to cabbage root fly, and that was shown by Stan Finch, as Rosemary said. Blue sticky traps containing a lure catch more bean seed fly than traps not containing a lure, and I did those experiments in before last year, and I spoke about those in the presentation I gave last year. And we used the same lures that Becky used, but if you want more information about that, just contact me. What are the most effective methods of setting up a blue sticky trap so that more bean seed fly are caught? So this year I asked a few questions. So does the height of a blue sticky trap affect the number of bean seed fly to be caught? Does the orientation of a blue sticky trap affect the number of bean seed fly to be caught? And then, does the proportion of a blue sticky trap that is covered by insects affect the number of bean seed fly to be caught? So Rosemary was saying that as more insects attach to a trap, it may become more attractive to bean seed fly to attach to it. So that's why we asked that question. And why is it important to ask these questions? Well, once we've done all of these experiments and we've done all of the data analysis, we'd like to sort of recommend which sort of methodology is best to trap more bean seed fly than similar species. So when a grower is looking at a trap, they can be confident it's bean seed fly that they are looking at. So according to question number 1, I haven't spoken about the methods. If you'd like to know more about the methods, please contact me. These are graphs showing the mean bean seed fly per trap, and then the proportion of bean seed fly as a proportion of all of Diptera on the trap. We didn't find any significant differences with trap height, and that's all I'm going to say there really. Trap orientation. So we had a great master's student come and help us with this in the summer, and she did a lot of work. So I'm just showing some of the data she found now. She was looking at bean seed fly attaching to traps that were horizontal or curly. We used the curly orientation because that is what is advised when putting a lure on a trap, is that you curl the trap around it. But what we can see at the moment is that it looks like there were increased numbers of bean seed fly on the horizontal traps compared to the curly traps, and also an increased mean proportion of bean seed fly as a proportion of Diptera. However, I still need to do some of the stats tests on this data, so it is just a trend at the moment that we're seeing. And then finally, looking at the proportion covered by insects. So to ask this question, I didn't use real insects on the trap. I placed different percentage cover of black card on blue sticky traps to sort of mimic the insects that which would attach to the trap over time. So we had traps that didn't have any black card on, all the way to traps that had 75% of the surface area covered with black card. And what we can see is that there is a trend here for there being less bean seed fly caught on traps that have a higher percentage cover on it. And this is a mean bean seed fly count per 2 centimeters squared. So I still need to do some stats tests on this, but this is implying that if you leave a trap out for a longer period of time, it's going to become less attractive to bean seed fly because there's more insects caught on it. So just to summarise those findings, no, there isn't a significant influence of height on bean seed fly counts on a trap. Horizontal traps seem to catch more bean seed fly than curly traps. However, we need to do some stats tests here to prove that. And traps with less covering with black card seem to catch more bean seed fly. So looking at all of this information, what we can sort of advise at the moment, however, we haven't got the stats tests to back up some of this yet, is that blue sticky traps are good. A lure is good to attract bean seed fly to the traps. Horizontal traps seem to be better than the curly orientation. However, we need to just look at the data here. And considering that more bean seed fly are attracted to traps that are more of the surface area is blue than the black, I think it means that we need to leave traps out for less time, so 1 to 2 days. But I still need to do a lot of data analysis, and I've got quite a lot of data to go through, so that is going to be my job this year. But overall, we want traps that catch more bean seed fly than similar species. So conclusions so far. So looking at preventing damage, the timing of cultivation and covering of the crop can affect levels of bean seed fly damage. And what we know so far regarding monitoring, blue sticky traps containing a lure catch more bean seed fly. And so these fit into the 2 bottom levels of an IPM strategy for managing bean seed fly. I just want to say thank you to everyone for listening. Here are some pictures of the lovely people at Warwick Crop Centre, and thank you to Becky for your help along the way as well. And if you have any questions, let me know.
Great. Many thanks, Becca.
Thank you.
Right. Any questions, comments? Becky's first, and then Jenny.
Hi, Becca. That was really good. Thank you for that.
Thank you.
I just have one question, actually. When you did the curly versus horizontal trap experiment, was there a lure included, or was it all without?
So we did lure and no lure. So we had, in theory, 4 treatments, but in those graphs I was just showing the difference between the traps not containing lures. So I've still got that data, and I aim to go through it and have a look. I can get back to you on that.
Yeah, no, that's brilliant. Thank you.
Okay.
I was only asking because I was wondering how, I guess you just attach the lure at the top of the sticky and then let it hang down if you've got your horizontal.
Yeah, that was what, so I still need to go through that data, and it'll be really interesting to compare. But yeah, it was kind of attached over the top of the horizontal
the top of
section.
it. Okay.
Yeah.
Brilliant. Thank you.
Okay.
Jenny?
Hi, Becca. Yeah, just a really similar question, actually. I was just wondering, with the horizontal traps, have you got 2 sticks then holding them up?
Yeah. Yeah, I can send through a photo to you if that helps. But what I did is I hole punched both ends of the sticky trap and then sort of put 2 canes in the floor that were sort of the same distance apart as the trap, and then just sort of slotted the sticky trap through the holes through the canes. Hopefully that is.
And you held it up with rubber bands, did you?
Yeah. Yeah.
Okay, brilliant. Thank you.
You're welcome.
Excellent. Thank you. I guess, yeah, it's probably just worth saying that Becca's still sort of working on the biology of the bean seed fly, and as I mentioned earlier, it's sort of very different to cabbage root fly and onion fly, and the fact that it seems to carry on throughout the year. So she's also been looking at day degree forecasts and has spoken before about day degree forecasts. And I guess what we're trying to do at the moment is work out whether we need to kind of tweak those day degree forecasts, because we assumed at the beginning that they were overwintering like cabbage root fly does, and so you should start your day degree accumulation in sort of late winter. But it may be that we need to tweak it in some way. They obviously still seem to have most years a sort of big early peak, and so it's just to work out how you can get the best fix on that. And yeah, again, any feedback, comments about how useful I guess forecasting, monitoring information would be helpful as well, and I guess helpful for Becca when she's writing up her thesis. So yeah, Chris, would you like to ask a question?
Yeah, hi. It's a 2-part question really, but the lures on the traps, do they only attract bean seed fly, or do they attract cabbage root fly as well, or are the cabbage root flies just incidental things that end up on the traps?
The traps contain a volatile that is associated with onions and decomposing onions. So in theory, they should be attracting more bean seed fly than cabbage root fly. So they shouldn't really be attracting cabbage root fly. I still need to go through and do some comparisons with cabbage root fly on some of the traps, but that I didn't from when I did it, I don't think we caught. It was quite a low percentage of cabbage root fly on those traps containing the lure. So they should in theory make it more selective to bean seed fly, but that's something we still need to look at.
Okay, so part 2 would be, has anyone tried to design an enclosed trap so that only bean seed fly are caught? Because that reminds me of the days of maybe pea moth trapping, when you just had them in a container and they were just, because it would be great from a remote monitoring point of view if you could just come up with something that just had bean seed fly in it. But looking at the smiles on the faces, that's probably been looked at already, has it? Or
not yet, but I've got a plan in mind.
Are the blue is part of the attractants, is it, or could you enclose the blue and sticky trap in something so that the lure just brings them in and then they just stick on the trap? Or
I think you need the vision. You need the blue. You need the visual attractant. But I say we've got some thoughts about that. So yeah, watch this space. We just need to wait for more bean seed flies to be active to try them out.
Okay, and one more question as well, if I may, and I appreciate the extra time and cost involved is huge, but have you considered, or will you consider pre-covering of drilling areas? Because obviously if the cultivation itself has brought in bean seed fly activity, you could already have them in the system before you drill anyway, couldn't you? So would you trial covering soil pre-drilling? Or I know you got to take it off again, then drill, and then potentially put it back. So I get the cost and everything, but
I think that might be. So I see Phil's put his hand up now. So Phil could actually answer that question when he asks his.
Probably not, but my question was, anyway, going back to the traps, because we've looked at these camera traps and tried using those, and there seemed to be a bit of an effect from the cameras, the cover itself, on reducing a numbers caught, which we've discussed before. Have you managed to look at that at all? Or
the effect of the cameras, Phil?
Itself,
sorry,
yeah.
it was a bit blurry, the sound.
Sorry,
so yeah. No, we probably haven't pursued that in much more detail this year. I think the trouble, well, as you probably know, the trouble is we don't have enough camera traps to try with and without, but I did have an idea about sort of mocking them up to try that. But I think you're right that possibly the camera, because it's quite close to the trap, isn't it? It may sort of obscure some of the the visual field. I mean, I guess at the end of the day, well, you're wanting to catch enough numbers, aren't you, to show you that numbers are going up and down. So I guess that's what we're all aiming for. And selectivity would, if we could find a way of making traps more selective, that would just be absolutely brilliant. But yeah.
When Becky was saying sort of that you get sort of low counts but you're getting high damage, when I was having a think about that, and when we have traps on the blue sticky traps here that have loads of flies on them, most of them are male flies and a smaller proportion of female flies. So I don't know if that is corresponding to just male flies being in that area, whereas the female flies are going to be the flies laying eggs. So I was just wondering if there needs to be something maybe there is something that's more selective for female flies over male flies, and they might have a different sort of, there might be a different sort of chemical that attracts females to males. It's not been asked yet, but I wonder if that's something that needs to be focused on for sort of the selectivity and trying to find the female flies more than the male flies. That's just an idea.
Yeah, no, good thought.
Mm.
So I think Jenny's got a question.
Hello.
Comment.
I thought that was a really good point, because with other species, we normally have the lures are quite often pheromones, aren't they? Which are maybe more specific to the species, whereas we know it's a generalist, and yet we're kind of trying to use its food source to attract it, but it's kind of attracted to lots of things. So yeah, and that's interesting about the male and female flies, because I didn't really realize that, and I've had that before where we've been trapping, and it just seems a bit random and potluck. You can be trapping low numbers but still get damage in the field, or you can get high numbers and not damage in the field. So yeah, it does make the trapping quite confusing having that.
Yeah, I mean, I think the point is we just do not understand about about numbers in the landscape, which sort of partly refers to my earlier point about where are most of them completing their life cycle, and then yeah, we just don't know how they where they are and how they move around the landscape, and really hard to kind of work that out, I think. So yeah, great. Okay, thanks again, Becca. So we'll move on to Simon now.
Thank you. I'm still here.
Good. You haven't run away.
No, I haven't had any IT issues either, which is good. Let's have a look. If you could let me know if I'm sharing and everything looks okay.
Yeah, you just need to go into slide. Yeah, brilliant. Well done.
We're away, are we?
Yeah,
that's success for me.
Thank you. Yeah.
Okay. So good morning, everybody. Thank you very much for inviting me to talk. So we've my plans are a quick update on the seed treatment, then to talk about the granular products we've got, which are our kind of closest to market solution at the minute, and then to share some trials data. So that's where I'm going. Obviously, discussion, questions along the way. Perfect. Apologies if I won't be able to answer everything, but I'll try. So this was really just to remind me to talk about the seed treatment. So currently the AHDB have applied for an emergency approval for leeks and salad onions for the seed treatment. So that's in progress. In the background behind all this, obviously emergency approval is just 120 days, and we really need a longer term solution potentially. So in the background behind all of this, we have the palatability studies that we've been working on. All that data isn't in just yet, but once we get that, that'll be reviewed and shared with CRD, obviously. So that's work that's ongoing. From a rate point of view, kind of looking at future approvals, we have data on carrots, and it's very limited data, to be honest, but it does show efficacy, so that would be useful. And I believe the onion data from commercial trials would suggest that would be good control. So those are the two possible areas where we could go in the future for seed treatment again, and they are supportable. Other crops potentially we have a data gap for, unfortunately. And yeah, I don't know all the details about that, so apologies, but certainly onions and carrots are supportable. And then I suppose kind of where does that take us? Well, if everything happens as it should and the palatability studies look okay, and things progress after that through registration, it could be that we'll be in a position, this is a kind of a long shot or needs quite a bit of luck, but it could be that we'd be in position to have an approval again in 2024. So it's a bit of a watch this space, really. And just to credit CRD, they have helped us quite a bit with the stewardship and helped us kind of create a package that will allow us to do that again. assuming that all the other data is suitable. So that's all I've got to say about force seed treatment. I appreciate that was just a kind of a bit of a shot, but you know, there's obviously some questions that still need to be answered, like the palatability, etc. So it's a bit of a watch this space from here on. Okay, so yeah, this was something that Max shared last year, and it shows our pipeline. Obviously, you can see we've got in the middle there, we've got karate granules and Force Evo granules. Timelines always slip, unfortunately, and I think potentially Max was talking about this year for karate, and it looks, well, certainly not going to be 2023 now. It will be 2024 in all likelihood, and Force Evo will be after that, unfortunately. So we've still got a couple of difficult seasons potentially, where we haven't got a definite solution. And then further down the line, obviously, we've got other things that are coming to market. But if I'm honest, most of these are aphid focused. So things like bean seed fly will need specific solutions. And this doesn't capture everything. Obviously, there's other work ongoing, but certainly these are difficult pests, as you'll know. So to talk about the two products that we have, we've got a Karate 04 granule, and that's a lambda cyhalothrin based granule. And then we have Force Evo, which is tefluthrin with a foliar feed component in it. And these are, as you see, these are the sort of nearer to market solutions or possibilities that are coming through. So apologies if people have seen this before, but I don't know who was on the who's seen about these granules previously. So it's just a quick recap on them. So the Karate granule, as I said, it's a lambda cyhalothrin granule. It's contact and ingestion. There on the slide before it said low vapor, and it is very low vapor activity. So I've taken it off because and you'll see it's almost negligible, I think, really. So the focus crops really are maize and potato, and then vegetables. But it is a pyrethroid, so we thought it was an interesting product to look at with fly pests as well. Again, it's incorporated in the soil at sowing. It'll be an interesting product for potatoes if because it has a short harvest interval. So while we're in control with a short harvest interval is potentially an interesting product. And then Diabrotica is corn rootworm, I believe, which potentially is a maize or sweet corn problem. So one application, and the buffer zone obviously at the bottom there, 20 meters for all crops. So it says no buffer zone potato. I would need to check that, to be honest. That's something that looks a bit odd to me, so apologies. Force Evo, so obviously we know with tethruflin we have this vapor effect, and this is kind of what we think is most useful in controlling. So soil applied, and then we get vapor activity through the soil, which gives us a nice zone of coverage. And this is a veg-based product with you can see it's got a wide or broad spectrum of control of insects. So potentially things like symphalids, corn rootworm, flies, etc. And again, one application and soil applied in furrow at time of drilling. And just to recap, it has this nutrient component, which seems to have a kind of a synergistic effect with the tefluthrin, which means we can lower the tefluthrin rate and still get very good efficacy, or certainly in trials we've seen good efficacy. So just to highlight this vapor tension difference between the two pyrethroids, right at the top we have tefluthrin, and then as you look down you can see it's a massive order of difference by the time we get to lambda cyhalothrin, and I think probably it's negligible and not really a component of the product. So the difference would be, or the activity would be from contact and ingestion from lambda cyhalothrin. Just to kind of illustrate this graphically, on the left we've got the force granule, which is a bigger granule, so potentially more dispersed or more distance between the granules in the soil, but because of the vapor activity, you get a nice zone of coverage, whereas the karate granule on the right is a smaller granule, but that means we can distribute it more evenly around the seed. So if potentially we don't have the vapor, but we've got more chance of contact. So that's all I was going to say about the two granules. Hopefully that's a little recap if people have seen it before, and kind of explains a little bit about the granules for people who haven't seen it before. So just to go through some results we've seen now. Obviously, we've had limited trials in the UK. We didn't get fantastic results. We had some difficulties with establishment. Becky and Rosemary have talked about their trials, and they didn't get convincing results. So, you know, I've got some nice data, but I think we need to kind of test this again, test this in the UK, kind of prove what we're seeing. There's some kind of surprising stuff in here, but hopefully it's generally a positive message, and you know, it looks like there's a way forward, hopefully. So just to start, as I said, in the UK, the results weren't terribly convincing. So I did a kind of search for trials that we had in Europe, and we've got two trials from Europe on beans, and two trials from Europe on onions. So we have got some data. So on the left-hand side, where my highlighter is, this is the results as a percentage of the untreated. Now this site, there wasn't a very high bean seed fly activity, but it gives me an opportunity to talk through all the treatments and some of the features of the trial. So from a treatment list point of view, we have the untreated, then we have the forced evo granule, and then included in the trial, because it's good trials practice, we have a nutrient granule. So obviously the forced evo is tefluphenone with a nutrient component. So this is quite a nice check to have in here. We then have the karate granule, which is a lambda cyhalothrin granule, and then there's another pyrethroid granule with activity similar to karate. So low vapor activity. So the left-hand trial shows all the untreated at 100%, and the differences you can see in the assessment dates, in the different assessment dates, compared to the 100%. So in this trial, it seems to suggest that there is a kind of a slowing of emergence effect from all the granules, which is peculiar. It even includes the nutrient granule. But at the last assessment, the population is higher than the untreated. So as I said, very low bean seed or pest activity here, but just thought it would be interesting to point this out, and also just to give me a bit of time to talk through the treatments. Interestingly, karate didn't seem to have that effect, although the other coded product did. When we look on the right-hand trial, so this is another chance to explain the trial. This is the plant count over the 3 assessment dates. So you can see that plant counts were lower initially, but then finished up higher at the last assessment. And this beans, I think it was sown, it must have been May time. So apologies, I haven't got the sowing date on there. So the second bean trial, there was a bit of activity, 18% plant loss in the untreated, This is a trial in Belgium near Antwerp, and you can see again on the left hand side we've got the untreated as 100% at each assessment date, and you can see that the force evo, we have a emergence or a plant establishment higher than the untreated. Interestingly, the nutrient kind of copies the untreated, which is good, so it's like having a second check. The karate doesn't show much activity here, although the second product with a similar activity shows some activity again, not quite as good as the force, but there is activity there. And if we look at the plant counts, you can see a pretty similar trend to the percentage untreated. Okay, so this was stuff drilled at 10th of June, and then assessment started on the 16th. So you could see that already we had activity quite early after sowing. To move on to the onion data is a bit better, and we had certainly higher levels of activity in the onion treatment. So again, on the left-hand side, we've got the 100% for each treatment, each assessment date. You can see force evo has performed well here. The nutrient again has acted like a second check, and we've got this kind of result similar to the untreated. Karate has performed well, as has the coded one. And I guess this was slightly surprising to me that the karate granule was performing as in a similar way. Surprising and not surprising, we've got control of bean seed fly by a pyrethroid, and they're both pyrethroid products. So it's surprising, but it's also maybe not that surprising. When we look at the stats, we can see that the untreated and the nutrient are similar, no statistical difference, and then the two granules, so the karate and the force evo are statistically different. The third, the coded product is kind of between the two. So this was drilled 27th of April, with assessment starting middle of May, and again, a reasonable level of plant loss, and they kind of also saw some suppression in the untreated on plants that were there. So quite a nice trial from that point of view. And then finally, the fourth trial data. So just to say, the two bean trials were by different contractors, and the two onion trials were by different contractors. So using potentially different equipment. Just when we think about the comment about applying it, obviously these were applied by two different people. Okay, so this trial in France, north of France, the untreated again, on the left hand we've got the 100%, and then the assessments on the treatments are taken as part of that 100%. So you can see with the force, the emergence was better, and the plant count, the emergence plant count was much better than the untreated from start. The nutrient again is similar to the untreated, so a nice kind of second check. Karate again was giving us an effect, and the coded also. And then when we look at the stats, a nice kind of statistical difference between the untreated, similar to the nutrient, and then the three granular products, all showing a statistic difference from the untreated, and a good difference in plant number and establishment from the untreated. So the two onion trials are quite good. Just also make a point that this had fish meal applied post sowing, sowed again end of April, with assessment starting mid-May. So I guess just to kind of put us into a summary, and kind of to caveat Becky's and Rosemary's trials, obviously they saw these granules potentially in their trials. they didn't have the results we've seen here. So I think we need to, just be careful and do a bit more work to gain a bit more confidence. But this data does show some encouraging results. The Force Evo was good efficacy in all trials. Karate looked good in onions, but potentially the results weren't quite so convincing in legumes. And then there was that odd kind of slowing of emergence in one of the trials, and I don't know if that's a feature of the site or what it was, but certainly it was interesting that also the nutrient type granule had that effect as well. Okay, that was all I was going to say. I hope that's okay. And are there any questions, really?
Fantastic. Many thanks, Simon.
See if I can.
Becky, got a question?
Yeah, just one, Simon, actually, really. With the Force granules, it's an MP nutrition add-on, if you like, although at very, very low rates, of course, because it's 10% of 12 to 20 kilos. Do you have a view about how that's viewed by the Environment Agency, for instance, regarding legumes? Because in NVZs it's a 0N, legally max N is 0. So
yeah, that's I knew it was going to be an awkward question.
I mean, I've got my own view, but I just wondered if you'd been given any guidance about that.
No, I haven't been given any guidance, unfortunately. I'm hoping that because it's such a low rate, it won't actually kind of be any issue, really. Yeah, I guess. Yeah, I'm assuming that there'll be people who are doing nutrient type seed treatments as well, and that will fall into kind of a similar category, I guess.
They do, and I think often it's a grower decision, I suppose, in the sense that of how cautious they are about putting a treatment on that's got N in it and declaring that for the purposes of RPA, I suppose, in the end. But I just thought I'd ask if you knew.
Yeah, no, I haven't. That's something certainly we should investigate.
Okay.
Yeah.
Thanks.
Great, thank you. Right, so now's the slot for general. Well, yes, Kim's got a question. Great.
Yeah, hi Simon. I just wondered, in any of those trials, were you able to include Force seed treatment as well as a comparison, just to see how well the granules were doing against it, or was it not possible to do because it's not authorised?
Yeah, if I'm honest, I have asked the contractors what the commercial treatment is, but I haven't had anything back. Obviously, they're not people that I deal with regularly. It would be really interesting to know if if anything was done. Like you say, I suspect it was probably it wasn't, because it's kind of a little bit of an exclusive to ourselves. But yeah, I haven't had confirmation, if I'm honest.
Yeah, that'd be interesting to know, just to see how they're performing alongside the seed treatment. Not that it's, I mean, I know it's beggars can't be choosers, but it would just be interesting to see the comparison between the two tefluthrins.
Yeah, I mean, it's interesting, because obviously both Rosemary and Becky didn't get particularly good results with the granules, which yeah, does make me a little bit cautious. Although from the design of those trials, it does look like, it's almost like having a double check in both trials, and the results look quite consistent, and they do pass the statistics. So yeah,
I mean, when with Becky and Rosemary's trials, obviously the infestation level of bean seed fly was, or the damage levels was so high. I remember speaking to Max and him saying possibly even if we'd had Force seed treatment in there, it might not have worked either, because of that sort of very high pest pressure. and that the level of active that we were putting on with the Force Evo was potentially higher than with the seed treatment anyway. So maybe it was just too high pest pressure for anything to work.
Yeah. It's interesting that the limited data we did get from the UK on onions, it does actually show that I don't know if it's a bit unfair, but that there were good control in the good plots with force. Whether the poorer plots were just due to poor establishment, and the karate plots were consistently better than the untreated. So there is a little bit of trend there, but it needs further testing, really. I guess my problem is that when we think about France and Belgium, what is the mix of pest? Is there more onion fly? Is there, it could be other factors in there. So that's why I'm a little bit cautious about it.
Yeah. Okay. Thank you.
Great. Thank you. Right. So, has anybody got anything else they'd like to ask or comment on of any of the speakers? Richard?
Yeah, it's a comment about this male-female ratio on traps, and maybe getting a better indication of what populations of female flies are around. It's mainly aimed at Becca, really. I'm sure she's maybe seen this paper that was written back in the 1980s by two Japanese researchers who looked at the decomposing onion pulp as a way of attracting what they called seed corn maggot, which is in effect the same species of what we're talking about. And in that paper, they talk about ratios of female to male and playing about with the components. So basically, you've got 2-phenyl ethanol and then valeric acid in there in different ratios. And it might be just worth reinvestigating that paper. And it sounds like you've got the same sort of results as to what those guys found in the early 80s, and maybe trying to look at playing around with the ratios to see if we can up that proportion of females on traps to give you a better indication of what populations are around in the field and potential egg lay.
Thank you.
So, yeah.
Yeah, I have read those papers. Yes. Yeah, because we've got the traps from the people that Becky went to, so they had already sort of synthesized everything that was inside the traps already. And as far as I'm aware, it is I can't say it, but it's the same as they have used that research by Otter. I can't remember the names of them, but yes. But I have looked at those papers and sort of thought about what could potentially attract females over males when I was doing a bit of literature searching. I don't know if there isn't much research on pheromones in bean seed fly, and I don't know if there has in cabbage root fly or onion fly. I don't know if maybe pheromones might be more potentially a better thing for females. That's just an idea. But yeah, it could be that there are other sort of other. I'm not a chemist, so I'll be wrong by saying anything here, but like some sort of other component that attracts them, like you say. But yeah, it will have to be another research project, I can imagine.
Absolutely.
That.
Yeah, I think the valeric acid sort of seemed to indicate if you up the percentage of valeric acid in the lure, you would get a better catch of females. But yeah, like I say, it's another research project, isn't it?
Yeah, many questions.
Okay, thanks, Richard. Phil?
Yeah, question for Richard again. Any thoughts on nematode control? Do you think there's much mileage in it, or should we look at in-furrow treatments with nematodes as well, or what do you think?
Well, that's a good question, and if you go back to Becky's talk, she did indicate that there's some promise that we're seeing, particularly in Becky's work on vining peas, of in-furrow treatments with nematodes. It's not completely conclusive because, again, Rosemary had done some work with nematodes as well in some of those trials, which were done through the AHDB, and again with high populations, none of the treatments seemed to have any effect, including the nematodes. So I think the jury's still out, Phil. Certainly, I'm backing nematodes. You know that as a potential way of being able to at least suppress populations in furrow if you get the timing right and the rates right. And like I say, and like Becky did mention, we'll try and continue doing that work this year, in certainly in vine peas anyway, because the results actually are, as much as they're maybe not significant, statistically significant, that is, they are showing a positive trend towards some level of control or suppression, or improving, limiting damage, if you like, to the crop. So yeah, we're still backing that horse at the moment.
Chris?
Yeah, hi. I'm just revisiting my question earlier about covering pre-drilling. I don't know if Phil did answer that one, but he was quite broken up. I couldn't hear him very well when he spoke, so I don't know if you got a view on that, Phil, or whether you have actually looked at it on trials. I didn't pick up anything on that.
Yeah, we haven't done anything pre-drilling, no. Although again, I suppose if, in theory, it could work, couldn't it? If you've got if cultivated and there's a peak, and preventing them laying. If you're going to drill close to laying eggs, then I suppose yes, there can be a benefit. But again, trying to get the timings right again is the tricky one, really. You could easily just trap them all in there as well, I suppose. Yeah, it's
no.
Harder to time, I think. Harder to get the timing right, I think.
No, thank you.
I guess maybe, we should be thinking about all the components of an IPM strategy, and the sort of increasing the gap between cultivation and drilling does look promising. So I guess where that is feasible, that should be done to sort of take the pressure off any subsequent treatments. And I guess, yeah, that's what we should be working our way towards, is combining approaches, so that nothing is a silver bullet. So getting the best out of a combination. So Dan.
Good morning. Have you looked at a preliminary cultivation within the 7 days before doing a quick cultivation, and then again ahead of drilling on the day?
I'll answer that. Not really. No, I think there are often preliminary cultivations, but they tend to be quite a long way in advance of your sort of main cultivation. So most of our work has looked at your main cultivation being either on the day or those periods leading up to it. So not specifically, no. I might be able to find some data that includes that, but it wouldn't be very comprehensive, have to be honest. So
okay, thanks.
I don't know whether anybody else has got any thoughts on that. Oh, okay, right. So I think it looks as if we might have run out of questions and comments. So first of all, to say that if anybody thinks of anything afterwards that they wanted to say, or suggestions or whatever, then please, get in touch with us, because we're happy to try and follow them up in some way. And then I'd like to say thank you very much to all the presenters. So Becky, Becca and Simon. I think we've had a really good overview of the whole situation. We could probably do with doing that for a number of issues in crops. And thank you all for your participation. With the permission of the speakers, we'll put the presentations up on the website and say it has been recorded. So I'll trim the recording and upload that as well. And yeah, just thank you all for attending. And yeah, I guess we'll all try to carry on as much as we can addressing this problem in the future, which is still a knotty problem. So thank you.
Thank you. Thanks, Rosemary, for organising it.
You're welcome.
And we'll,
Thank you.
Thanks, Rosemary. Thanks all.
Thank you.
Thank you, everyone.
Bye.
Bye.
Bye. Bye. Bye.
Thank you.